I've just been like slightly crying. This is being recorded.
It is.
Is it really?
Of course. We don't want to miss out on everything that we've done.
You guys.
Yeah. Here we go.
I went to the Lawson first.
All right. So Rolle's theorem helps us with the mean value theorem, and the mean value theorem just says if f is continuous on a closed interval again between a and b, and it's differentiable from a to b, then there's a number c in the interval such that f of c equals f of b minus f of a all over b minus a. Let's talk about what this all means. Okay. Ooh, this is the slope equation. This is the slope. It's the slope equation of what?
The derivative of the tangent line?
At C.
Or at, okay.
You guys are almost there. Great. I'm just going to draw some random graph. Here's A and B. F has to be continuous, okay, and it has to be differentiable. There's no other parameters, so we don't have to have the height of the y values be the same. So say we just have this. Here's F of B. If I follow this up, what is this value here? The height there. What would we call that? This is A. What would we call the height?
F of A.
F of A. And if we follow this up here, we go to the cross here, this is F of B. Alright, so here we go. Here's F of A, and here's F of B. I want you just to think about that for a minute.
Wait, why is it suddenly now that they don't have to equal each other?
Because this is a different.
It's right.
Okay. So is that a secant line that we're finding this slope? Or
So
just-
when we look at, so we'll go back to what Keely said. She said she recognized that to be the slope. And like Joe just said, he said that's not just this, that's the slope of A to B. So if I draw that in,
But
here,
that's not the line though, that's just the average slope. We're not finding the actual slope all the way across the line.
right, when you find, like you said, here's this line. This is the point A, comma, F of A. And this point here is B, comma, F of B. So Jasper, what you just said is you're finding the average slope, right?
Mm-hmm.
When we find the average slope, we're finding the slope of the secant line, right?
Yeah.
You guys all agree that this is the average slope. It's the same thing as the slope of the secant. So back to here, Keely said slope. Joe said add that in, secant. And Jasper said it's just the average slope. So this theorem states that
Oh wait, so that's a secant line?
that is the secant line.
like the letter C.
And the theorem states if we have a slope of the secant line, there has to be, what does this represent? F prime of C. What does that represent? What is F prime of C? You guys all know that.
Height
What's F prime of C?
The slope of the tangent line
Yeah.
at C.
It's just the slope of the tangent line. Just the slope of the tangent line. This is the slope of the secant line here. This is the slope of the tangent line. So this theorem states if we have a slope of a secant line, there has to be a slope of a tangent line where those two slopes are equal. Okay? So here I'll draw it in, then I'll make it a little more clear. Here's my C. And there's my tangent line. This is my tangent line. And here is C. There has to be some value C where the slope of the tangent line. Those slopes are equal. How do you know that they're equal?
They're parallel.
Because they're parallel. Right. So there has to be some kind of parallel line here where the slope of the tangent equals the slope of the secant. Again, between any given interval A and B.
So if this line is a secant line, then it also has a tangent line, and the secant line and the tangent line are parallel.
If there's a secant line between A and B, there has to be a tangent line within that interval that has an equivalent slope. So how would we do this?
How would we show this?
Well, you would. How do you find a secant line exactly?
Like it says right there.
How would you find the secant line? Well, if you're given an
Oh, wait, never
interval,
mind. So okay, so we have the mean value theorem with the interval 0, 2. So then we can enter 0, 2. Okay, wait. So that's just one point that we have, right?
this isn't a point. This is an interval,
Oh, that's the interval.
right?
Okay,
It's an
so
interval
then we
between 0 and 2.
Okay, plug in 0 into the equation and
Okay.
plug in 2 to the
Let's do
equation to
that.
get the two legitimate points.
So you're doing the secant slope right now, right?
Yeah, let's just
so
find the secant
let's start with the secant slope, and let's find f of 2 minus f of 0 over 2 plus 0. All right, f of 2, Keely, f of 0, Jasper, and then I'll do 2 minus 0.
Well, it's just 0.
6.
So we get 6 over 2, which is 3. So that's the slope of the secant line, right? There has to be some value on our tangent where the slope of the secant line is 3. So we've just done this part.
Wait, so f derivative of c is 3.
Has to equal 3. There has to be some point of the derivative.
So then after we find that, then do we do number 1 and 2? Or is
Oh,
that-
we should actually probably state that. Number 1 and 2, is it continuous? It's a polynomial, yeah, it's
So, yeah.
continuous. Is it differentiable? Yes, it's differentiable. So we can use the mean value theorem.
So then we'll,
Gotcha. Yeah.
So we find the derivative, right?
yeah.
Now you find the derivative. Find the derivative. So we find, here's y. Let's find y prime.
3x squared minus 1.
Now what do we do with that?
We'll put c as x and then set it equal to 3.
We said that the slope of the secant and the slope of the tangent have to be equal to each other. So we found the slope of the secant. Now we just say, well, that has to be equal to the slope of the tangent at this point. So let's find that point. So I have 4 equals 3x squared. 4 thirds is x squared. And then x is plus or minus 2 root 3, which is really plus or minus 2 root 3 over 3 if I rationalize the denominator. But we just have to double check. Does that fall within our interval? Does C value fall within our interval? Here's our interval, 0 to 2.
Both of them don't have to, right? Just one of them.
Just
Yeah.
do any of them. So what is C going to be then? Not the negative one, it's only the positive 2 root 3. So find the slope of the secant, set it equal to the slope of the tangent, and
Wait,
find your C values.
Why did you? Where did you get plus or minus 2 over square root of 3 from? Because isn't it just x equals the square root of 4 thirds?
And the square root of 4 is 2, and then root 3 at the bottom. I just simplified it.
Okay, so then